Welcome to Siemens Online Registered Installer Training, Module 3, Copper Testing and Termination. First off, we're going to start with copper testing. Our next few slides will walk us through some of the different configurations and the test equipment required to perform copper testing. For starting, you really need to identify the proper test equipment. As identified here, all of your installed cabling really needs to be 100% tested and documented for warranty. In terms of requirements for the actual test equipment itself, the specifications are you need at least a level 2E tester for testing category 5E, a level 3 tester for testing category 6, and a level 3E tester for testing category 6A. Generally a good idea to have a level 3E tester simply because you're able to test, the backwards compatibility. So if you have a level 3E tester, you can test category 5E, 6, or 6A. And there's a number of manufacturers out there. Fortunately, there's not too many of them out there. But for a list of approved testers for the different systems, you can go to our partner support center at www.siemens.com/ally. Key things in terms of making sure your test equipment is in good shape is ensuring you have the latest software or firmware available for the units, ensuring that it's factory calibrated on schedule and all the default settings, you don't have a custom setting still left in there from previous testing, and that you're using the qualified test cords for either permanent link or channel. As we noted earlier in the training modules, testing a permanent link is probably the most common method for testing, simply because the permanent link is comprised of the two connections at each end as well as the horizontal cable. And there could be an optional consolidation point in the middle if that's used. And I think the reason that people prefer to do that simply is because you have a certain confidence level, obviously, that if you would use patch cords at the end, everything will work. But patch cords can change, so doing channel testing is kind of unique to that specific the specific patch cords being used at both ends of the channel. So permanent link is simply a little bit more common method for testing. Keeping in mind that testing the permanent link does not include the permanent link adapter cords that attach to the copper testers. Simply both connectors, or a third if there's a consolidation point, and the horizontal cable. As we also mentioned earlier, the modular plug terminated link is a little bit of a unique configuration. In this case, the testing of that, because the end device, the plug at the end that plugs into the equipment, is actually going to plug into the tester itself, the test actually evaluates the performance of the horizontal cabling and the one connection in the TR. The connection of the Z plug into the test adapter, or the modular plug in that end, is not qualified, simply because that's not factored in as part of performance testing measurements. So it excludes the permanent link adapter on one end as well as the adapter on the far end, the Z plug it plugs into. Interesting point of note here is that in this case, that adapter is not a channel adapter. It's not just a standard channel adapter with an RJ45 port. It's actually a patch cord adapter, and there's just different offsetting calculations that have to be made to take that plug out of the equation for the modular plug terminated link test. So it's always good to confirm that test with your copper test manufacturer to ensure that the setup matches this configuration, but that's generally the configuration you're going to see used for testing MPTLs. And finally, we have channel testing. Channel testing effectively includes everything in the channel, the connectors, the cable, the cords, everything right up to that last plug jack interface where one end of the patch cord plugs into the test adapters, and that's simply just not part of the defined channel. So there's everything you could have in there. It could be a cross connect in there, it could be a consolidation point in there, it could be both in there. Testing of the whole channel really defines exactly what the equipment will see when it's actually in operation. The only consideration for the channel, as we noted previously, is that once the patch cord is changed, technically the channel values change, so it's not usually a common form of testing, but it's great for qualifying the end-to-end system should there be any issues in the field. This slide identifies a list of test parameters that you're going to see when you're using one of these level 2, 3, or 3E copper field testers. And what you see here is simply all the different transmission parameters. Now, a couple of those highlighted, or I say, kind of whited out, shaded out in gray, are test parameters you're probably going to see reflected on the test equipment, but they're not pass-fail. They're for information only. So you won't, even if there's a number on there, you're just going to see an NA in terms of pass-fail, or an information bullet like an I on the screens there. So you're going to be testing, and this happens usually in about 10 seconds or less for the wired map, including a shield, if there is testing for shielded cable, just the presence of the shield continuity from end to end, the insertion loss, the length, the near-end crosstalk pair-to-pair, the power sum near-end crosstalk, which is the power sum of all the crosstalk combined, attenuation to crosstalk ratio far end pair-to-pair, as well as the power sum version of that, return loss, propagation delay, and delay skew. And it's actually pretty impressive that this test equipment can do all that in such a short period of time and put that all out there. Now, coming up, we're going to show some of the various termination methods for our key copper products. In some cases, there'll be videos in conjunction with PDF links, and in some instances where we don't have videos, they'll just be PDF links, but you'll have the opportunity to see in great detail here. And it's important to understand how these products are terminated properly. In a lot of cases, people kind of will just grab them and kind of go at them, but what you'll find here is a lot of great tips and ideas created by our technical services group to provide sufficient detail and proper information for proper termination of these products. So we're going to start with the max outlets. We do have video instructions for both the punch down version, where you use a single position impact tool, as well as the use of a max turbo tool, which terminates all the conductors with kind of a single operation. We also provided a link to our detailed instructions that are available in PDF.
The S310 style termination is used in several of the Siemens Company product lines, including the CT6 series, both angled and flat, all Max series modules, both angled and flat, and the HD6 series patch panels. All styles are compatible with both T568A and B wiring options. The S310 blocks feature a pyramid Y entry system to help separate conductors when lacing in cable, and any standard single position 110 style termination tool may be used. Rear protective termination caps will accommodate any 4-pair flat or round cable types for both rear and side entry applications. The cap design allows for installation onto the cable before or after termination. Start by stripping back approximately 50 to 60 millimeters or 2 to 3 inches of cable jacket using the Siemens All-Prep tool or equivalent. Although round cable is shown here, flat cable may also be used. If a pair separator or ripcord is present, remove with snips close to the jacket, being careful not to nick the conductors. There is no need to untwist pairs except for bonded pairs, since the 310 block includes the pyramid features to facilitate wire lacing. View the color-coded label on the module to determine proper location of conductors based upon the preferred wire scheme. For additional stability and protection, the palm guard and or palm guard insert can be used for the CT6 and Max series modules. Because of the small design with the Max module series, it is highly recommended that the palm guard insert be used with these modules. Note that the palm guard insert can be used alone or in conjunction with the palm guard itself. Fan out the conductors based on the desired wiring scheme. Depending on the cable and manufacturer, it may be necessary to cross over 2 of the pairs for proper orientation. When terminating the Max series modules, insert the module into the palm guard insert. Center the cable jacket down into the 310 block as shown here. Lace all pairs by pressing firmly into position. Optionally, 2 pairs can be terminated first to help secure the cable before lacing the final 2 pairs. Terminate the conductors using the Siemens S814 termination tool or equivalent. To prevent damage to the thinner side walls of the S310 block, be certain the blade is in line and not angled as shown here before impacting. If the blade angle is not carefully controlled during impact, in extreme cases, the sidewall and contact may end up damaged and unusable. Note that it might be helpful to slightly angle the blade side of the tool as shown here to assist in termination. It is also recommended to use the low impact setting to maximize module stability during termination. Inspect the terminations to verify all conductors are seated properly. Also verify the edge of the cable jacket is down into the 310 block as shown here. Finally, slide the termination cap onto the cable and snap into place prior to testing. Use of the cap ensures that the conductors are fully seated and provides a degree of strain relief, but care should be taken to prevent side loading, particularly at the patch panel when dressing in cable bundles. For mounting locations with limited rear clearance, tilt the cable 90 degrees to the side as shown and lace as described previously. Note that modules cannot be side stacked if side entry is used. Cap removal can be accomplished by prying with a small screwdriver placed in the slot as shown here.
Siemens Max Turbo Tool is a 4-pair mass termination tool for use with any of the Max series punch-down style outlets. There are 3 different styles: flat, angled, and keystone. The Turbo Tool is designed with features to accept each of these versions. For simplicity, this video features the angled Max version, but the flat and keystone styles are loaded into the tool in a similar way. Remove approximately 2 to 3 inches of cable jacket and arrange the 4 colored pairs in accordance with the chosen wire scheme. Use of the optional palm guard insert will help stabilize the outlet while lacing the conductors in place. Position and hold the cable end down against the color-coded wire scheme sticker. Untwist each pair enough to press into the corresponding lacing post. Each opening has retention features to hold the lace conductors in place prior to termination. After lacing each pair, check the position of the conductor ends. For easier fit when loading into the tool, these conductors should be fairly straight and perpendicular to the outlet as shown here. With the conductors properly laced, load the assembly by positioning the outlet with a flexible latching arm opposite the metal retention latch of the tool. The holder has features to accommodate the Max flat, angled, and keystone styles as shown here. All 3 versions are positioned with the latching arm of the outlet opposite the metal retention latch of the tool. The outlet can be used to move the retention latch when loading into the tool. The module should slide into place and click past this latch once fully seated. Ensure that both the module and cable are seated completely down into the base of the tool to prevent a mistermination. Once seated properly, squeeze the handles of the tool together as far as they will go to terminate. The excess conductor ends will shear off, and the ratcheting mechanism will release once the handles are fully cycled. The outlet can now be removed by pushing up through the bottom opening while flexing the retention latch out of the way. Finally, press the clear termination cap into place and the termination is complete. Eventually, the blades of the tool may become dull or the module holder may wear. Siemens offers a replacement cassette and holder kit that can easily be installed as needed. Using the Allen wrench included, remove the securing screws counterclockwise as shown. The retention latch will also need to be removed temporarily in order to replace the holder. Periodic lubrication at each hinge location will help to keep the tool operating smoothly. A thin coating of lubricant can also serve as a protective barrier against oxidation of the metal in a moist environment.
Next up is our ZMAX outlet, and as you can see, we actually have 3 different videos really designed to illustrate the termination methods of the 3 different types of ZMAX connectors, which is simply the shielded, the unshielded, as well as the 45-degree ZMAX shielded outlet, which allows you to mount a shielded outlet in kind of a shallow mounting application where the cable doesn't exit directly out the back. A little bit of a different type of termination for that. In addition, we've provided links below for the PDF instructions for these products. It includes one supplemental bits of instruction for terminating using OSP cable, which sometimes has a little bit of additional challenges as it relates to cable preparation for termination.
Before termination, verify that all required tools and packaged parts are available. Each bag of parts should include the ZMAX outlet, the termination module, and the icon set. Required tools include the Z-tool, a cable preparation tool, a small flat screwdriver, and a flush cutter. Prepare the cable by stripping approximately 2 inches or 50 millimeters of cable jacket.
Remove any ripcord if present, then invert and pull back the foil layer on top of the jacket. Ensure that the foil is flat and completely unfolded with only the conductive side facing out. For best transfer impedance of the ground path, we recommend also wrapping the drain wire on top of the foil, close to the edge of the cable jacket.
Isolate any fillers or pair separators from the conductors, and trim off close to the jacket, being careful not to nick any conductors. Now arrange the conductors without crossing any of the cable pairs according to the preferred wire scheme, either T568A or T568B as depicted on either side of the termination module. With the cable in the proper orientation, flex all 4 conductors up slightly and lock into the termination module with the cable retention clip. Be sure the clip captures the cable jacket and not the conductors for proper strain relief. With the cable secured in the module, untwist and lace each pair following the color code shown for proper tip ring arrangement. Simply hold down each pair just before the beginning of each lacing channel. Relax the twist by spinning the conductors a couple times in the direction opposite the factory twist, then press into place. The cable retention features in the lacing channels will hold the conductors in place. Be sure that no conductors are protruding above the lacing channels before proceeding. Using a flush cutter, trim all 4 pairs even with the lacing channels and double check for proper lacing. The conductors should not protrude beyond the shelf shown here in the module. Now prepare the outlet for termination by aligning the keyed portion of the termination module shown here with the keyed slot provided in the back of the ZMAX outlet. Insert the termination module into the outlet as far as it will go. You should hear the latch, shown here, click past the first retention bump on the module. The second retention bump will lock the module in place when terminated with the Z tool. To complete the termination, orient the ZMAX outlet opening in accordance with the RJ45 shape of the keyed lever and insert. Now depress the cam lever to complete the termination. The back of the termination module should now be flush with the housing. Panel mount outlets are virtually identical to workstation outlets, but do not include the colored bezel. Terminations are identical. The innovative design of the ZMAX workstation outlet allows the same module to be mounted in either a flat orientation or an angled orientation. The angled orientation can be accomplished by rotating the module 180 degrees and snapping into place using the mounting slot provided further back in the housing. The modules can be snapped in from the back as well as the front to allow for more flexible installation options. Each ZMAX outlet comes with an icon set including a color-matched blank and printed icon, and a printed blue and red icon depicting both phone and data symbols. Icon pockets are provided for both the angled mounting options as well as the flat mounting options. In the event of a miswired outlet, the ZMAX can be re-terminated. Use a small flat screwdriver inserted into the slot provided on the back of the outlet to disengage the latch. Alternately, a spare icon could also be used by inserting in place of the screwdriver. Grip the outlet housing tightly, pull the cable and module out the back.
If the module does not release easily, the screwdriver can be used to pry out as shown here. Be careful not to slip if using this method, and note the exact position and angle of the screwdriver to accomplish this successfully.
Hi everyone, this is our new ZMAX 45 outlet. The cable will exit at a 45-degree angle sideways, either out to the top right or the bottom left. And I'm going to show you a termination with a shielded Category 6A cable today. So we have the outlet body, the lacing or termination module, the rear cover, and then you get a tie wrap as well. This is the termination tool. This makes termination a little easier because the termination lacing module is so small, as you can see. This tool has multiple functions, and one of them is to hold this lacing module like so. So this is keyed. It won't go in very easily the wrong way. Insert it into the module and you're ready to go here. So let me prep this cable. So you want to take off about 2.5 inches. That works the best. Any strip tool will work. The foil layer you want to fold back on top of the jacket like so. Drain wire in this case gets folded back. I'll show you what to do with that in a moment. Remove the mylar layer and the center separator. Just be careful not to nick the conductors. Now, anyone that's familiar with our Z-Max outlets, lacing is identical to that. Wire scheme options, as you can see, are listed both on the bottom of the module and on the tool handle itself. But the arrangement is identical to our Z-Max series. So I'll do the B scheme today for you. So brown, blue, green, then orange. Okay, so the jacket edge should butt up against this rib here in the tool handle. That will give you the measurement required to the point of termination. So let me lace this here for you. White conductor, if you're right-handed like me, will be to the left or away from you from this point of view. So as far as the pair untwist, as you can see, in some cases I have the pair twist pretty high here. That should still work fine. It's okay to have no twist like this brown one. You're still well within, recommended distance for your first twist. So with the bigger cable, if you're using 22 gauge, I probably wouldn't recommend having that first twist so high. So in that case, you may want to untwist that one more time and lace in like this. That'll make termination a little easier. So once that's laced in, you can remove the module by either pushing up on the cable, or you can grab the back end. Just be careful the conductors do not pop out on you. Flush cutters at this point are recommended. I wouldn't recommend using electrician scissors, but if you cut fairly flush with the scissors, that should work as well, but it's best to have a pair of these diagonal cutters or flush cutters on hand. Okay, at this point, you're going to use the termination tool. So it works best if you load your outlet body into the tool like so. There's keying features on both sides of the lacing module. Two different shapes. I don't know if you can see it too well, but there's a kind of a rectangle shape here and then a kind of a V groove here. So it is keyed to only go in one way, but you could force it in the wrong way. But just remember, when your outlet's loaded into the tool, your conductor side or your cables, your conductor should always be on the upper side. So just start this into the back of the module and then rotate your handle so that you can depress your outlet flush against the base. Make sure that's flush before you do your termination, so you're just compressing the rear cap into place by depressing the handle like so. And now you've got your termination done. So your lacing module should be flush. That way you know you have a good termination. Now at this point you decide, okay, which way do I want my cable to exit? If your thumb latch side is down, which is what we recommend, so your contacts should be up so you don't get dust settling on them. So if you're mounting this into a faceplate, that's your typical orientation for a flat mount. So you can either have your cable exit top right or bottom left, like so. You just need to decide ahead of time. Okay, so get your cable oriented accordingly. Take your rear cover. This will snap on either direction, but this is the cable exit side. So orient that accordingly. Make sure your cable is roughly in the right position. Start your cap, press that into place. And then now you take your drain wire. It works best now to wrap this drain wire at this point. Either direction. Sometimes it's easier to go one way versus the other, but ideally you want to wrap it whichever way makes more sense to you, depending on where the drain wire is coming out. Now notice I threaded it through the opening of the outlet body. That's very important. So wrap that around into the same spot where the tie wrap is going to go. Oops. Okay. Make sure that's in the same exact location and laying flat as best you can before you insert your tie wrap. Your tie wrap is going to compress that against the cover and the body to give you the best transfer impedance for your ground path. And you do want to cinch this down as tight as you can with your fingers, with your hand. You can position the knot of that tie wrap anywhere you want. It's usually out of the way on this side, but it's up to you. Cut off your excess. And you're ready to install. So it is important to have that drain wire captured, with the tie wrap, like so. Okay, so removal, you can re-terminate this up to 4 or 5 times. You will need an extra tie wrap though, so just cut off your tie wrap. You can take a small screwdriver to wedge it into the slot here to pry that cover off. Unravel your foil, or in that case it broke off, but now you're just pulling this apart. There's no latching feature like you may have seen with our Z-Max. So if you can grab this with your fingers tight enough, you can pull that fairly easily. Oops, in this case the cable's so short it pulled out on me, but you get the idea. Now if you're having trouble holding on to this, there is a feature in the tool. It's hard to see, but there's a little ridge here on the leading edge of the tool. There's also some features on the handle that are designed to accept the module to give you some leverage. So you would insert it into the tool like so. You're not using this piece in the middle. That's just laying flat. You're just resting it right on top like this. Okay. So it fits together kind of like a puzzle piece. That'll grab the outlet, give you some leverage to hold on to this, and then you can kind of work this out comes out fairly easily, so most cases you won't need the tool, but so that's how you remove that for reterminations. Okay. Any questions? Look us up, Seaman.com, and I'll call our tech support line. We'd be glad to help you out.
The following video details termination of Siemens' new ZMAX UTP outlet, featuring many truly innovative design aspects, providing a rapid, repeatable, and reliable termination process with adaptable mounting and labeling options. The termination also features Siemens' new Z tool for the ultimate in lightweight, compact, rapid termination aids. Before termination, verify that all required tools and packaged parts are available. Each bag of parts should include the ZMAX outlet, the termination module, and the icon set. Required tools include the Z tool, a cable preparation tool, a small flat screwdriver, and a flush cutter. Prepare the cable by stripping approximately 2 inches or 50 millimeters of cable jacket. Isolate any fillers or pair separators from the conductors, and trim off close to the jacket, being careful not to nick any conductors. Now arrange the conductors without crossing any of the cable pairs according to the preferred wire scheme, either T568A or T568B as depicted on either side of the termination module. Prepare the module for attaching to the cable by unlatching the hinged cable retention clip. The clip can easily be unlatched by placing pressure on the clip arm while releasing the latch shown here. A small flat screwdriver can also be used to unlatch the clip. With the cable in the proper orientation, flex all 4 conductors up slightly and lock into the termination module with the cable retention clip. Be sure the clip captures the cable jacket and not the conductors for proper strain relief. As an alternate method for securing the retention clip, the keyed lever of the Z tool can be used for additional leverage. Place the prepared cable and termination module sideways into the molded impressions provided in the tool as shown. The clip side must be up and facing the keyed lever. While supporting the cable and termination module, rock the keyed lever onto the spring clip to snap the latch into place. With the cable secured in the module, untwist and lace each pair following the color code shown for proper tip ring arrangement. Simply hold down each pair just before the beginning of each lacing channel. Relax the twist by spinning the conductors a couple times in the direction opposite the factory twist, then press into place. The cable retention features in the lacing channels will hold the conductors in place. For best performance, maintain the factory twist in each pair up to the entrance of each lacing channel. Be sure that no conductors are protruding above the lacing channels before proceeding. The wire scheme is provided on both sides of the module, so proper lacing can be verified from the back even after the conductors obscure the colors from the front. Using a flush cutter, trim all 4 pairs even with the lacing channels and double check for proper lacing. The conductors should not protrude beyond the shelf shown here in the module. Now prepare the outlet for termination by aligning the keyed portion of the termination module shown here with the keyed slot provided in the back of the ZMAX outlet. Insert the termination module into the outlet as far as it will go. You should hear the latch, shown here, click past the first retention bump on the module. The second retention bump will lock the module in place when terminated with the Z tool. Prepare the tool by lifting the cam lever and the keyed lever. To complete the termination, orient the ZMAX outlet opening in accordance with the RJ45 shape of the keyed lever and insert. Now depress the cam lever to complete the termination. The back of the termination module should now be flush with the housing of the ZMAX outlet. As an alternate installation option, the Z-tool comes with a mounting hole provided for hands-free operation. The tool can be mounted to a wall or to the rail of a rack as shown here to assist during the termination of multiple cables. Panel mount outlets are virtually identical to workstation outlets, but do not include the colored bezel. Terminations are identical. With the latch orientation down, these outlets easily snap into place from the rear of the panel as shown here. Removal is accomplished by simply defeating the latch at the base. Cables are easily secured with tie wraps on the integrated cable manager. No threading of the tie wrap is necessary. Simply loop around the cable and the open-ended tie lance of the patch panel. With this open-ended tie lance design, the tie wrap can also be looped and started away from the panel where access is more convenient, then slid along the cable and pinched into place as shown before securing. The innovative design of the ZMAX workstation outlet allows the same module to be mounted in either a flat orientation or an angled orientation. The outlet locks into place but can easily be removed with either a flat screwdriver from the front or by simply depressing the latch with your finger from the back. The angled orientation can be accomplished by rotating the module 180 degrees and snapping into place using the mounting slot provided further back in the housing. The modules can be snapped in from the back as well as the front to allow for more flexible installation options. Each ZMAX outlet comes with an icon set including a color-matched blank and printed icon, and a printed blue and red icon depicting both phone and data symbols. The individual icons are easily removed and snapped into place as shown. Icon pockets are provided for both the angled mounting options as well as the flat mounting options. In the event of a miswired outlet, the ZMAX can be re-terminated. Use a small flat screwdriver inserted into the slot provided on the back of the outlet to disengage the latch. Grip the outlet housing tightly, and while holding the screwdriver in place, pull the cable and termination module out the back. Alternately, a spare icon can also be used by inserting in place of the screwdriver.
Here we have termination information for the Z-plug, which is typically used to terminate modular plug terminated links. We have video instructions available, as well as the PDF instructions that also includes a supplemental addition for working with OSP shielded cable.
Siemens' new Z-plug offers quick, reliable Category 6A field termination using a termination module that is compatible with a wide range of cable types and gauge sizes. This video will detail the step-by-step termination of the Z-plug, including cable preparation variations for several common 4-pair cables, including shielded, unshielded, and outside plant constructions. Verify that all required components and tools are available. Components include Z-plug body, the termination module, Z-plug boot, and colored latch protector clip. Note that the optional colored latch protector clip is offered in various colors. The plug and clip can be ordered separately if a color other than black is desired. Required tools include flush cutters, any cable jacket strip tools such as our CPT RGTP tool. The optional green stripping die is recommended for extra large cable jackets, such as with our shielded outside plant cable. The Z-plug termination tool will also be required and is included with every standard pack or bulk pack of Z-plugs. Finally, a small flathead screwdriver may also be helpful if any re-terminations are necessary. Slide on the optional boot narrow end first. Note that for larger outside plant cables, such as our Category 6A version, the boot will not fit without modification. The tapered end of the boot can simply be trimmed if necessary. The boot is recommended but only required if the colored latch protector clip is being installed. Cable preparation for several cable types are included in this video. The Category 6A shielded version is primarily shown throughout the lacing and termination process, but these steps are identical for all other cable types as well. The cable preparation variations needed for other cable types are included at the end of this video. Strip off approximately 2.5 inches or 63 millimeters of cable jacket. Traditional UTP construction will only require the removal of the ripcord and center pair isolator. UTP cable with a foil crosstalk barrier, such as our GT cable, will also require removal of this foil barrier layer. This should be cut off as close to the jacket as possible. A ground path connection to this discontinuous foil crosstalk barrier is not required. These types of UTP cables are treated exactly like a traditional UTP cable after removing the crosstalk barrier. If using typical indoor shielded FUTP cable, invert the foil layer and pull down on top of the jacket such that the conductive side is facing out. This should be lying flat, unfolded, and covering as much of the jacket as possible. For best ground path transfer impedance, the drain wire should also be wrapped around on top of the foil. Wrap this drain wire neatly in the same direction of the door swing on the termination module to prevent it from unraveling during the door closure. Next, remove the cellophane layer, ripcord if present, and the center pair isolator. Following the desired wire scheme depicted on the termination module, arrange the pairs in preparation for insertion. Both T568A and T568B wire options are shown on the sides of the termination module. Pair crossing may or may not be necessary depending upon the chosen wire scheme and which end of the cable is being terminated. For larger conductors, it is important to arrange the pairs in line as neatly as possible to facilitate easier insertion into the module. Arranging larger pairs properly is critical for proper fit and best performance. Any necessary pair crossing should be done prior to insertion into the termination module. With the cable and pairs arranged properly, insert into the termination module and position with the jacket edge or shield layer high enough up to make solid contact with the door and ground clips. For larger cables, it will help to seat the cable into place with your finger before starting the door closure. With any of the larger diameter cables, it may be necessary to use the Tool Assist feature to help with the door closure. The features on the tool will cradle the termination module and provide the necessary leverage to close the door. Ensure the cable is seated properly to prevent the door latch from deflecting up out of position, as shown here. Once the door is closed, the excess foil can be trimmed off. Next, follow the chosen color scheme and press each pair into the lacing channels by spinning once or twice in the opposite direction of the pair twists and pulling over the lacing post. Use diagonal or flush cutters to trim off the excess as close as possible. Orient the termination module with the blue and brown side facing the side of the plug housing with the double cutout. The module is keyed to only go in smoothly in one orientation. Insert until the latch clicks into that first position, then use the Z tool again to fully terminate. The latch will click into the second opening in the plug body and the module should end up flush with the housing. If the boot is being used, slide up and snap both latches into position. It may be helpful to bend the cable slightly in order to provide more clearance for the latch, as shown here. The colored latch protector is simply oriented and snapped into place. A protective dust cap, part number ZP-CAP, is also available as an optional accessory and can be installed into the front of the plug while awaiting final installation. The Z-plug is reusable up to at least 3 times in the event of a miswire. Simply remove the boot and disengage the latch by using the features on the underside of the tool handle. While pressing the latch side of the plug against the tool handle, pull on the cable and gently rock the module out. Once removed from the housing, the door can be opened using your finger or a small flat screwdriver. The cable can easily be removed by inverting and pulling out all 4 pairs at once. Fully shielded SFTP constructions such as our 22 or 23 gauge Terry cable will typically require one variation to allow for proper fit. Some constructions will be too large to allow proper closure of the door on the termination module. In these cases, the exposed braid layer can simply be wrapped on top of the foil pairs instead of on top of the jacket, thus keeping the jacket just outside the termination module. as with the drain wire, wrapping the braid neatly in the same direction of the door swing on the termination module will prevent it from unraveling during door closure. If using the CPT tool to score the foil pairs, only rotate the tool around one time with the tension on the handle relaxed to prevent cutting into the conductors. If using outside plant cable with a water blocking gel component, this gel should be completely wiped off from each individual pair. Note that some of the water blocking gel may leak out under certain conditions. The gel is non-conductive but may result in unwelcome discharge at the back of the plug. There are commercially available cable sealant kits made for sealing the cut end of gel-filled cables, but may not be practical for use with a direct termination to a modular plug. The extra large diameter of the outside plant category 6A UTP cable may cause some difficulty when attempting to close the door of the termination module. In these cases, one or both of the ground clips can be removed in order to provide more room and subsequently much easier door closure. The ground clips are primarily for shielded cables, but do provide some cable retention with smaller diameter UTP cables. With these extra large diameter unshielded cables, the ground clips really serve no purpose and can be removed if necessary. If terminating directly onto 4-pair shielded outside plant cable, such as our category 6A FUTP that has 2 jacket layers, the outer jacket can be removed such that it remains outside the termination module. The Kevlar strands should be cut off as close to the jacket as possible to expose the foil and inner jacket. The conductive side of the foil is already facing out on this layer, so this foil-wrapped inner jacket can be used for connection to the termination module, similar to an FUTP indoor cable. Finally, the water blocking gel will also need to be wiped off from each individual pair. As mentioned with unshielded OSP cable, some of this non-conductive gel may leak out under certain conditions. The installer may want to take steps to isolate any unwelcome gel discharge over time. UFTP shielded construction may also be used, although not as common. This shielded cable only contains foil-wrapped individual pairs, but no overall shield wrap. As such, at least one of the foils and drain wire must be used for proper ground path connection. The other 3 foils on the remaining pairs can be removed close to the jacket. Unwrap one of the foils from the twisted pairs and rewrap around the outer jacket, ensuring the conductive side is facing out. Again, for best ground path connection, the drain wire should be wrapped around on top of this foil. In cases where smaller diameter constructions are used, such as stranded 26 gauge FUTP, it will be necessary to build up the jacket to a suitable diameter for a solid ground path connection to the shield when closing the door on the termination module. This is fairly easy to accomplish by cutting a 1/2 inch or 13 mm slit in the cable jacket, enough to invert the jacket on top of itself, creating a double jacket layer. The shield layer can now be inverted on top, then continue termination as with solid cable.
For our S110 blocks, which are a little bit of a legacy style product, we don't have video instructions available. However, we do have information on PDF format for step-by-step termination instructions. And the same applies for our S66 blocks. These PDF instructions cover the termination for our M150 block, which is the most common block, but the same concept applies to the various termination blocks for the 66 family. So that wraps up Module 3 of Siemens Online Registered Installer Training. We're going to proceed now to Module 4, Fiber Cabling.